All right, welcome to the first set of notes for the year. We will be talking about 1-1 negative exponents. Learning intentions for today is going to be able to take negative exponents and convert them to positive exponents and vice versa. This is going to help us when we start computing with scientific notation, and we will know what we are doing when we can easily convert between negative and positive exponents and back and forth. First thing we're going to cover is some background information. This is going to be parts of a fraction. Now, the first thing we're going to talk about is the numerator. The numerator is going to be the number on the top, and that is the number that we are dividing. All right, the second part of a fraction is the number on the bottom, and that's going to be the number of equal parts we are dividing the numerator into. The next piece of background information we have to talk about is the parts of an exponent. The first part we have is the actual exponent. That's going to be this little number up here. I put an n, which just stands for any number. All right, and the exponent is the number of times the base is multiplied by itself. Then, of course, we have the base. That's the a in this one. That's just the number being multiplied. Pretty simple. Continuing to talk about regular exponents, right? We can think of regular positive exponents as the result of repeated multiplication. So here we see we have the base 7 raised to the exponent of 3, which means we are going to have 7 times 7 times 7. And that will equal 343. So if positive exponents are the result of repeated multiplication, negative exponents can be thought of as the result of repeated division. So here we have x to the negative 3, which means we will have 1 divided by 7, divided by 7, divided by 7, which will be the same as 1 divided by 343, which will be the same as 0.00292. I rounded there. That's okay. So the technical definition of a negative exponent is any number raised to the nth power is the multiplicative inverse of its positive nth power. Now that sounds like a lot of gibberish, but let's see what that looks like in algebraic terms, right? We have x, which is just any number, raised to the negative n exponent, and that is going to equal 1 over x to the same number exponent. It's just now positive. So all you have to do to make a negative exponent positive is take the inverse and put it at the bottom of a fraction. Or if it's already on the bottom of a fraction, as in the second case here, you just bring it to the top, and now you just have x to the n power. All right, so it's a real simple case of getting rid of a negative exponent. You just take the inverse. If it's on the numerator, you bring it to the denominator. If it's in the denominator, you bring it to the numerator. All right, let's see what that looks like in practice here. So we're going to evaluate 4 to the negative 2 power, negative second power, which is going to equal 1 over 4 to the second power, or 1 over 4 squared, which is going to equal 1 over 4 times 4, which is equal to 1 over 16, which is equal to 0.0625. All of those are equivalent expressions. They all mean the exact same thing. That's what the equal sign means. You can also use negative exponents to rewrite algebraic expressions. So here we have 1 over y to the negative third power. And to make that positive, all we did was we took the inverse, which would meant bringing it from the bottom to the top, and now we have y cubed. And that's all there is to that. If you have any questions, please make sure you bring them in on Monday. And if you want to, for some extra credit, write and solve one problem involving negative exponents on your own. Thank you very much. Have fun.